In the boundless silent ocean of the cosmos, where time unfurls in dimensions beyond our immediate grasp, and the quiet ballet of celestial mechanics plays out across unimaginable scales, there are moments, fleeting and profound, when the universe chooses to whisper its deepest secrets directly to us, drawing back the veil just a fraction. Such a moment, pregnant with possibility and shadowed by an almost cosmic awe, arrived not with the familiar fanfare of human endeavor, nor the triumphant roar of a rocket launch, but with the quiet, persistent gaze of a robotic eye, patiently sweeping the distant, pristine mountains of Chile. On the 1st of July, a subtle anomaly, a faint, almost imperceptible smudge of light, was meticulously catalogued within the voluminous, ceaselessly flowing data streams from the Atlas telescope network. This was not merely another asteroid, one of countless billions, tracing ancient, predictable orbits within our solar neighborhood, nor was it a distant comet, following its familiar, icy path towards the sun and then out again into the dark. No, what NASA subsequently detected and, with a growing sense of urgency, confirmed, was something far more enigmatic, a presence that would ripple through the global scientific community and stir the deepest, most primordial wells of human curiosity and apprehension. It was a mysterious presence, traveling through the unfathomable vastness of space, its true nature concealed within its colossal speed and its silent, relentless approach. An interstellar visitor, a new, unbidden guest that has been tentatively named 3 Atlas. Yet, to truly appreciate the profound and potentially transformative implications of 3 Atlas, to grasp the full weight of its significance, we must first cast our minds back, allowing our consciousness to drift across the expanse of 8 fleeting years. It was a time when the heavens, with subtle grace and an almost mischievous hint of revelation, unveiled the very first known interstellar object to unambiguously enter our solar system. This was a profound, unprecedented event in human history, a cosmic milestone that forever altered our understanding of our place in the galaxy, transforming us from potentially isolated islanders to inhabitants of a vast, interconnected cosmic sea. It would swiftly engrave itself as one of the most mysterious and debated encounters in the annals of modern astronomy, and it was bestowed with a name resonant with its journey, a Hawaiian word that hums with the essence of its nature, Oumuamua, meaning a messenger from afar, arriving first. The very sound of its name, a gentle murmur of discovery and wonder, carries with it the echoes of ancient voyages, uncharted territories, and the tantalizing possibility of messages from beyond our own sun. The initial discovery of Oumuamua, made in October 2017 by Robert Warwick using the keen digital eye of the Pan-STARRS telescope in Hawaii, was initially met with a heady mixture of scientific excitement, intellectual puzzlement, and a dose of almost childlike wonder. For decades, scientists, peering through their theoretical lenses, had theorized the sheer statistical inevitability of such interstellar wanderers, fragments cast out from the violent birth or chaotic evolution of distant star systems, hurtling through the galactic void like cosmic flotsam. But to actually see one, to capture its faint light, to track its unique path, and to begin measuring its physical properties was an entirely different matter. It was a tangible, empirical bridge to other stellar shores, a direct physical link to the universe beyond our immediate neighborhood. Unfortunately, the serendipitous and late circumstances surrounding Oumuamua's detection meant that our ability to truly unravel its deepest secrets was severely, almost tragically, constrained. By the time this peculiar, swift-moving guest was definitively discovered, Oumuamua was already a phantom on its retreat, having made its closest, most intimate pass to the sun some 40 days prior. It was now rapidly accelerating away from us, a cosmic whisper fading into the cold, silent depths of interstellar space, disappearing as swiftly as it appeared. This swift, uncatchable departure left astronomers with a tantalizing yet frustratingly brief window of observation, a cosmic tease. All that could be determined from the precious fleeting data were a series of perplexing anomalies, characteristics that defied every known astronomical convention, an unexplained, non-gravitational acceleration that simply could not be accounted for by the sun's pull alone, a most unusual and highly debated shape, unlike any celestial body we had ever encountered or imagined, and perhaps most strikingly a profound absence of any of the telltale cometary or asteroidal characteristics, such as a glowing coma or a streaming tail that would typically These were not minor deviations. These were fundamental challenges to our established models. It was precisely these glaring incongruities, these profound deviations from every known astronomical norm and expectation, that propelled some of the most respected and intellectually courageous minds in science to propose an extraordinary, almost whispered hypothesis. What if Oumuamua was not merely a random cosmic rock, a lump of ice or stone, a piece of inert debris, but rather an artificial probe, a silent, technologically advanced sentinel of extraterrestrial origin? This audacious notion, at once exhilarating in its implications and profoundly unsettling in its potential consequences, began to take root in the scientific imagination, forcing us, as a species, to reconsider the very boundaries of the possible and to confront possibilities previously confined to the vibrant, yet often dismissed, realm of speculative fiction. The very fabric of our cosmic isolation was beginning to fray. Now, however, the appearance of Oumuamua, with all its lingering questions, its tantalizing hints of something more, and its legacy of scientific debate, may soon be entirely overshadowed by an event unfolding, not in the past, but in our present, in the quiet, unfolding moments of time. At this very moment, another interstellar object, colossal in its physical presence and accelerating through the void at speeds that challenge our very comprehension, is approaching our solar system. Its exact origins, shrouded in the incomprehensible distances of the galactic plane, like the depths of a half-remembered dream, are yet to be definitively determined, cloaked in the vast interstellar distances from which it emerged. It has been given the moniker of 3 Atlas, echoing the robotic observatory that first captured its elusive light, and just like its enigmatic predecessor, Oumuamua, it has arrived from the unfathomable, star-dusted expanse of interstellar space. But this time, the stakes feel palpably higher, the signs appear even stranger, imbued with an almost deliberate precision, and the potential implications, both thrilling for the promise of discovery and potentially far more dangerous for our fragile civilization, weigh heavily on the minds of those who watch the skies with a mixture of wonder and trepidation. The cosmic silence, it seems, is being broken, not by sound, but by immense, swift-moving shadows. According to the esteemed scientist Avi Loeb, a distinguished professor of astronomy at Harvard University, a figure renowned for his willingness to challenge conventional scientific paradigms and courageously embrace the extraordinary, and his diligent, analytical colleagues, the observed trajectory of this new object is simply too precise, too impeccably plotted, to be merely a product of random gravitational dance. It presents itself not as a billiard ball erratically ricocheting through a cosmic game, but more like a calculated flight path, a meticulously orchestrated journey through the complex gravitational tapestry of our solar system. It is as if some unknown intelligence with a profound understanding of astrophysics had intentionally charted, adjusted, and maintained its course, guiding it with purpose. This meticulous, almost surgical, navigation suggests the unnerving possibility that our own blue planet, Earth, with its bustling life and its radiating technological signatures, may be its primary point of interest, a target of observation. Adding to this already profound and unsettling mystery is its truly enormous speed. 3 Atlas is traveling at an astonishing velocity, an almost inconceivable pace, almost twice as fast as the vast majority of known natural objects within our solar system, making it an anomaly of speed alone. This visitor, however, isn't just remarkably swift, it is also, quite literally, a true giant of the cosmos. For context, let us recall Oumuamua. Despite its deeply mysterious nature, its unique attributes, and the profound questions it raised, Oumuamua was, by astronomical standards, relatively small. Its dimensions were estimated to be about 330 to 380 feet long, a length roughly comparable to that of a single American football field. An ideal size for a reconnaissance probe, perhaps, a small and nimble scout, or merely an easily overlooked fragment of a larger, long-destroyed object. But this new object, 3 Atlas, stands in stark, awe-inspiring contrast. It is, by all preliminary estimates, literally hundreds of times larger than Oumuamua. According to the early, yet deeply unsettling calculations, its diameter could conceivably reach anywhere from 6 to 9 miles, a colossal scale comparable to that of an entire island city, like the famed Manhattan Island. To fully grasp this, imagine an object the size of a small metropolitan area, moving at unimaginable speeds, appearing from beyond our star, an unannounced guest. With dimensions of such staggering, almost incomprehensible proportions, the hypothesis of a technological origin for 3 Atlas no longer feels like the fanciful musings of science fiction. It begins to feel like a chillingly plausible, if not an almost inescapable conclusion. The sheer scale, combined with its other anomalies, pushes the boundaries of conventional explanations to their breaking point, demanding a more profound consideration of the extraordinary. As you allow these thoughts to gently settle, perhaps while gazing at the quiet ceiling, or simply letting your mind drift in the pre-sleep stillness, understand that 3 Atlas is, at this very moment, steadily, relentlessly approaching the orbit of Mars. Its swift, silent journey continues, a testament to the scale of the cosmos. Soon, it will begin its final, dramatic journey toward Earth, a path meticulously observed, calculated, and anxiously analyzed by our most powerful instruments and our most brilliant minds. So allow yourself to sit back, to get truly comfortable, to let the weight of the day lift from your shoulders, and to let your mind open to the wonders and the profound questions we are about to explore. You are about to delve into something truly fascinating, a narrative unfolding in the silent, star-dusted theater of space, a story that might redefine our place in the universe. What exactly could this colossal, mysterious object truly be? Could its unprecedented, swift arrival truly be connected to Oumuamua's fleeting, enigmatic visit 8 years ago, acting as a precursor, a harbinger, to something far grander and more consequential? And perhaps, most pressingly, as it draws closer and closer to our world, diminishing the vast cosmic distances with every passing moment, should we genuinely be worried about its intentions, or are we simply witnessing another natural marvel, albeit an extraordinary one? The questions hang in the air, echoing in the quiet chambers of our minds. The true chronicle of 3 Atlas, the moment it transitioned from an unknown potential to a recognized presence, truly began to unfold on July the 1st of this year, a day that may well be remembered as marking a subtle yet seismic shift in humanity's cosmic awareness. It was then that astute astronomers working from their remote stations in Chile, diligently poring over the vast, continuous streams of digital data emanating from the robotic Atlas telescope network, first spotted the strange object. The Atlas system, an acronym for the Asteroid Terrestrial Impact Last Alert System, is typically deployed with a critical, planet-saving mission to constantly scan the heavens for potentially Earth-threatening asteroids, acting as a tireless sentinel, safeguarding our fragile blue planet from cosmic impacts. Yet, on this particular day, its routine vigil became something far more profound. It became an accidental pioneer, capturing the first faint, elusive signature of a visitor from beyond our immediate stellar neighborhood, an unexpected messenger from an unknown star. This initial detection, given the object's anomalous characteristics, quite naturally and almost immediately raised profound concerns, a ripple of unease and intense scientific interest within the global scientific community. The initial images, those first tantalizing glimpses, relayed across continents through networks of fiber optics and meticulously analyzed with a potent mixture of scientific rigor, computational power, and sheer, almost incredulous disbelief, revealed not a familiar comet or asteroid, but a tiny, yet intensely glowing dot. This point of light was not stationary, nor was it moving with the leisurely, predictable grace of typical celestial bodies bound by the sun's gravity. Instead, it was racing through the cold, silent expanse of space, a solitary, unblinking beacon against the infinite, indifferent tapestry of distant stars. But what truly stunned the scientists, what caused their collective breath to catch in their throats, was its utterly astonishing speed. Calculations, performed with the highest degree of precision, quickly confirmed an almost incomprehensible velocity. It was covering an unfathomable distance of over 130,000 miles per hour, translating to approximately 36 miles per second. This was a velocity that immediately signaled its non-gravitational bound status, its interstellar origin. To truly grasp the immense, almost dizzying scale of this velocity, allow your mind to journey with me across familiar, earth-bound landscapes, to bring the abstract cosmic numbers into relatable human terms. Imagine the vast stretch of the continental United States, the distance from the bustling, vibrant metropolis of New York City on the East Coast to the sun-drenched, sprawling shores of Los Angeles on the West Coast, a journey of approximately 400 miles. A commercial passenger airplane, even operating at its optimal cruising speed, would typically require about 6 hours, a significant portion of a day spent suspended in the sky, to traverse this great expanse. 3 Atlas, however, with its incredible, almost surreal velocity, could cover this entire distance, from one coast to the other, in an almost unbelievable minute and 7 seconds. Its speed is so immense, so utterly extraordinary, so fundamentally unbound, that even the formidable gravitational pull of our own sun, the very anchor of our solar system, the celestial giant that holds planets in its sway, is simply insufficient to keep it bound within our celestial neighborhood. This object is not merely visiting, it is simply passing through, an uncatchable whisper in the cosmic wind, a fleeting shadow against the backdrop of eternity. Within a mere 24 hours of its initial, startling detection, experts at NASA, utilizing their most sophisticated computational models and their vast reserves of astronomical data, ran detailed calculations and recalculations. They meticulously cross-referenced every available data point, every faint flicker of light, every subtle shift in trajectory. These rigorous, painstaking analyses swiftly confirmed the boldest, most audacious suspicions that had begun to circulate among the astronomers, the whispers of an unprecedented event. The object had indeed arrived from the unfathomable depths of interstellar space. At the precise moment of its discovery, it was situated deep within the distant orbit of Jupiter, the largest planet in our solar system, approximately 327 million miles from our comfortable vantage point here on Earth. As you are listening to these words, perhaps drifting deeper into a state of quiet contemplation, allowing your mind to wander through the cosmos, it has already traversed much of that immense light-year-spanning distance, now rapidly approaching the orbit of Mars, continuing its relentless, rapid approach toward us, a silent, swift, and colossal giant from another star system. The clock of the universe ticks on, and with it, the approach of the unknown. Scientists, following established astronomical protocols and the quiet, formal language of cosmic discovery, bestowed upon it the official designation of 3 Atlas. This name, while precise, belies the profound questions it has already unleashed. Now, with its confirmed interstellar origin and its baffling characteristics, the truly pivotal questions, the ones that resonate deepest in the human psyche, that tap into our primordial fears and our most profound hopes, are brought sharply into focus. What exactly is this object, this silent, swift titan from beyond our sun? And could its unannounced, unprecedented arrival pose a tangible, existential threat to humanity, to our fragile civilization on this small blue world? These are not questions to be lightly dismissed or easily answered. They are profound inquiries that demand our most serious collective consideration, for their answers might redefine everything we understand about our place in the universe. Harvard astronomy professor Avi Loeb, a figure known for his willingness to challenge conventional paradigms, to ask the uncomfortable questions, and to courageously embrace the extraordinary, asserts with unwavering conviction that we possess every compelling reason to believe we are not merely observing another inert celestial object, such as a run-of-the-mill asteroid or a common, dusty comet. He postulates, with a compelling blend of rigorous scientific reasoning and intellectual daring, that the object currently approaching Earth with such astonishing speed and precision is, in fact, a sophisticated piece of technology, an artifact meticulously crafted by an extraterrestrial civilization. And, according to his incisive analysis and that of his team, this advanced colossal visitor may very well present a serious, unprecedented threat, or at the very least, a profound challenge to our understanding and security. Loeb and his esteemed colleagues, including Adam Hibbert and Adam Kroll, arrived at this startling and controversial conclusion after undertaking an exhaustive, meticulous analysis of all available data pertaining to 3 Atlas. Their findings, when finally synthesized, interpreted, and presented, proved to be truly shocking to many within the scientific establishment, causing ripples of debate and skepticism. The object's trajectory through the intricate gravitational ballet of our solar system, they found, was singularly unique, almost impossibly precise. It moved not with the chaotic, unpredictable grace of a natural wanderer, a random piece of space debris, but with the calculated elegance and unwavering focus of something perfectly mapped, a pre-programmed flight plan executed with flawless precision through the cosmic labyrinth. This suggested intelligence, not chance. Consider for a moment the intricate, almost choreographed dance of its journey through our solar system. Currently, this monumental object is hurtling toward Mars, the red planet. On October the 2nd, it is projected to pass approximately 17.5 million miles from the crimson surface of Mars. At first glance, such a distance might seem immense, an almost unfathomable void, reassuringly far away. Yet in the cosmic lexicon, in the grand, sweeping scale of the solar system, 17.5 million miles is practically within arm's reach. A close encounter that allows for significant and detailed observation and interaction from an advanced probe. The next planetary rendezvous on its meticulously charted itinerary is our home, Earth, the blue jewel. On December the 19th, the object will reach the point of its closest proximity to our planet, a still considerable distance of about 167 million miles. While this is certainly a vast separation in human terms, it represents the absolute closest it will approach us during its entire swift journey through our solar system, making it a critical, fleeting moment of observation. Following its Earth flyby, its trajectory then appears to guide it with unerring precision toward Venus, our scorching twin planet. This pass will be even closer than its approach to Earth, a mere 60 million miles. After this final inner solar system encounter, 3 Atlas will then begin its outward journey, heading inexorably beyond the gravitational embrace of our Sun and back into the interstellar void from which it came. A traveler departing. But before its final, complete departure on its return path through the outer reaches of the solar system in 2026, the object is slated to pass Jupiter, the gas giant, at a remarkably close distance of just 33 million miles. This is a distance that, for a planet of Jupiter's immense size, is a truly close pass, almost a cosmic embrace. The cumulative analysis of its entire intricate path is truly astounding. It reveals that the trajectory of 3 Atlas, combined with its extraordinary and unwavering speed, allows it to flawlessly execute close passes with no less than 4 distinct planets of our solar system, a kind of grand planetary tour, including our own Earth. Researchers across the globe, even those skeptical of the artificial hypothesis, have deemed this series of perfectly aligned close encounters to be nothing short of incredible, defying easy explanation. Their sophisticated astronomical calculations, performed and cross-referenced by independent teams, have rigorously demonstrated that the likelihood of such a precisely aligned route, encompassing so many close planetary passes, occurring purely by random chance, purely by the laws of probability in a cosmic game of billiards, is less than a vanishingly small 0.005%. This infinitesimal probability challenges the very notion of random cosmic events, forcing a deeper inquiry into the nature of its journey. In simpler terms, to help us grasp the sheer improbability, statistically speaking, in 99.995% of cases, an interstellar object would simply hurtle past our solar system, a fleeting, indifferent ghost, without any noticeable, significant, or orchestrated interaction with any of our planets. It would be a solitary passage, unconcerned with the worlds it passed. Yet, this particular visitor, 3 Atlas, seems to be following a trajectory that is anything but random. It appears to be a path of very deliberate intention, a carefully plotted course. Avi Loeb posits with an air of profound conviction that this extreme precision, this almost choreographed, elegant journey through our system, serves as clear and compelling evidence of advanced technology. He suggests it is most likely a sophisticated spacecraft, meticulously engineered and dispatched, with a specific purpose, to undertake a comprehensive study of as many planets within our solar system as possible, with our own blue marble, Earth, naturally being a prime target for its silent, intelligent, and perhaps inscrutable gaze. The precision is simply too high for coincidence. Inevitably, this raises a logical yet deeply intriguing question that tugs at the threads of scientific speculation and intellectual curiosity. If 3 Atlas truly is a spacecraft, a marvel of engineering created by an advanced extraterrestrial civilization, Why was its trajectory not specifically designed to achieve the absolute closest possible pass to Earth? After all, if the primary mission, the fundamental objective, is to observe and perhaps even analyze intelligent life, to gather the most intimate details about our civilization, it would logically follow that approaching our planet as closely as technically feasible would yield the richest, most detailed data. Instead, the object is set to pass nearly 10 times closer to Mars, the ancient, rust-red planet, than it will to Earth. This apparent preference for Mars, or at least a greater proximity to it, prompts a whisper of a thought. Could it be that to them, to this unseen intelligence, Mars, with its ancient, rust-red landscapes, its long-dead oceans, its geological history, and its potential for past extinct life, presents a more intriguing, or perhaps a less complicated subject for research than our teeming, unpredictable world? Or is there another, more subtle, reason for this curious deflection? Avi Loeb, with his characteristic blend of bold, unconventional thinking and reasoned, rigorous speculation, offers an explanation that is both perfectly logical within its extraordinary premise and utterly fascinating in its implications, adding layers of complexity to the mystery. In his view, this seemingly indirect trajectory, this avoidance of an ultra-close approach to Earth, is not an accident of cosmic chance, not a random gravitational wobble, but rather a deliberate and strategic choice, an intentional design feature. If there is indeed an intelligent life form on board, whether biological or an advanced artificial intelligence, it may be consciously and intentionally avoiding too close a contact with our civilization. This prudent distance, he suggests, might be a fundamental aspect of its mission parameters, a non-interference protocol designed to prevent premature revelation, to avoid startling us, or to mitigate unforeseen risks that a closer approach might entail, both for them and for us. That is precisely why the object's trajectory is arranged, so that the moment of its closest approach to Earth will occur on the opposite side of the Sun, from our perspective here on Earth. At that very precise moment when 3 Atlas is nearest to us, yet cunningly hidden from our direct gaze, obscured by the Sun's blinding light, it will be perfectly illuminated by the Sun itself. This positioning, while deeply frustrating for Earth-bound observers who wish to scrutinize it, would, conversely, offer an ideal vantage point for the object itself to conduct thorough studies of our planet, bathed in full, unobstructed solar light, using whatever advanced instrumentation it possesses. The Sun, from its perspective, would be perfectly positioned to highlight Earth. However, and here lies the profound, almost Machiavellian cunning of such a maneuver, because the Sun will be directly positioned between us and the object, acting as an impenetrable shield of light, we will be rendered effectively blind, unable to observe it in detail ourselves. Our most powerful optical telescopes would be dazzled, our radio telescopes overwhelmed by solar interference. According to Loeb, this seemingly inconvenient alignment for us may not be a coincidence at all, but a deliberate, calculated maneuver, a sophisticated act of cosmic espionage. They, this unseen intelligence, want to study us, to gather data, to understand our world and perhaps our species in meticulous detail. But they do not, it would appear, want us to study them, preserving their anonymity and their strategic advantage. This implies a level of caution, a strategic intent, and perhaps even a degree of suspicion that adds layers of complexity and apprehension to its visit. The scientist's subsequent hypothesis, building upon this foundation of strategic stealth and careful observation, is no less surprising and perhaps even more profoundly unsettling in its implications for humanity's future. If 3 Atlas is indeed a spacecraft, a sophisticated vessel designed by an advanced civilization for an explicit purpose, it may not, contrary to initial assumptions, intend to leave our solar system at all. Instead, it could be poised to employ a sophisticated gravitational maneuver, a masterful piece of celestial navigation, leveraging the immense gravitational field of either the Sun or Jupiter by applying the so-called Oberth effect. This effect, a cornerstone of advanced space travel, allows a spacecraft to gain or lose significant velocity by firing its engines while it is moving at its fastest, typically during a close pass to a massive celestial body. The energy gain is maximized when the engine burn occurs at the point of greatest gravitational potential. For instance, if the ship were to choose Jupiter, the colossal gas giant, as its gravitational anchor and energy source, it would not only need to approach the planet as closely as safely possible, daringly skimming its immense atmosphere, but then, at the precise moment of maximum speed and gravitational interaction, it would activate its powerful propulsion systems. This carefully timed burn, executed with exquisite precision, would allow it to dramatically adjust its trajectory, enabling it to either enter into a long-term orbital motion around the Sun, perhaps settling into a stable, distant orbit near Jupiter's expansive domain, or to dramatically slow its interstellar velocity, allowing it to become gravitationally bound to our Sun. Those same powerful engines, applied with precision and sustained power, could then be utilized to decelerate the colossal craft as needed, allowing for an extended period of observation and study within our solar system, perhaps setting up a long-term base. Such sophisticated maneuvers are not mere theoretical constructs or flights of fancy. They have long been a fundamental and proven part of our own human space exploration lexicon. Almost all of humanity's planetary research missions, those intrepid probes dispatched to unravel the mysteries of our solar system, routinely employ planets for gravitational assists. These cosmic slingshots harness the immense gravity of planets to either accelerate or decelerate a spacecraft, utilizing the planet's gravitational pull in a symbiotic combination with onboard propulsion systems to achieve otherwise impossible speeds, conserve fuel, and reach distant destinations with greater efficiency. It is a fundamental principle of modern celestial mechanics. According to Avi Loeb and his discerning colleagues, if this immense object is primarily an exploration vessel, a scout of monumental proportions, a silent observer designed for deep reconnaissance, then remaining within our solar system for an extended, perhaps indefinite period is precisely what it would require to study us, our environment, our burgeoning civilization, and the intricate dynamics of our solar system as thoroughly and meticulously as possible. This lingering presence, perhaps initially undetected or simply uncomprehended by our limited instruments, would transform its visit from a fleeting, transient flyby into a prolonged, silent observation, a sophisticated, long-term cosmic surveillance mission of profound and potentially transformative implication for humanity. The thought of a city-sized alien probe quietly studying us from the outer reaches of our solar system for decades or centuries is a concept that truly stretches the imagination. Another deeply fascinating aspect that captivates Loeb's analytical mind, compelling him to trace its implications, is the profound mystery surrounding 3 Atlas's point of origin within the vast, star-swept expanse of our Milky Way galaxy. Its calculated path, when traced backward through the intricate gravitational currents and stellar motions of the galaxy, leads not from a desolate star-sparse region, a quiet backwater of the cosmos, but from a rather bright and densely packed part of our Milky Way. According to Avi Loeb, this too may not be a mere coincidence. It could be a deliberate choice, an aspect of its design or mission. He hypothesizes that due to the exceptionally high density and radiant brightness of stars in that particular area of the galaxy, a region teeming with luminous suns, the object would have remained virtually invisible, naturally cloaked and camouflaged against their intense, overwhelming glow for a considerable duration of its journey. It would have been a silent ship, hidden in a sea of light. Had it emerged from a region with lower stellar density, a darker, more quiescent corner of the galaxy, a region with fewer stars, we would almost certainly have spotted it much, much earlier, affording us a longer lead time for observation, for study, and perhaps even for some form of preparation or response. The brightness of its origin might, paradoxically, have served as its cloak. Loeb believes, with a hint of what-if regret and a sense of missed opportunity, that had we discovered 3 Atlas at least a year earlier, humanity might have had enough time, precious, critical time, to prepare and launch a specialized spacecraft, perhaps a fast interceptor probe. This hypothetical interceptor, armed with advanced instruments and propulsion, could have been dispatched to meet it, to fly alongside it in formation, and possibly even perform a successful landing, securing an unprecedented opportunity for direct, in-situ study, a moment of profound revelation. But it appears, he muses with a touch of melancholy, that 3 Atlas, or the intelligence behind its intricate design and journey, has no desire to become a target for our nascent research, preferring to maintain its inscrutable distance, its veil of anonymity. The window for such a proactive intercept, he fears, may have already closed, leaving us to observe from afar, delving even deeper into the temporal scales of its journey, stretching our minds back into the deep past. Calculations show that at its astonishing, unwavering speed of 36 miles per second, 3 Atlas crossed the outer boundary of our solar system, the hypothetical distant realm of the Oort cloud, approximately 8,000 years ago. This distant, vast, spherical shell of icy bodies, thought to be the birthplace of long-period comets, marks the true gravitational edge of our sun's dominion, the outermost frontier of our stellar neighborhood. It is a boundary of profound significance, where the sun's influence gives way to the vast, cold emptiness of interstellar space. The scientist emphasizes that this particular period, 8 millennia in our past, stretching back to a time almost beyond recorded history, was a time of truly remarkable and transformative changes unfolding on Earth. Humanity, then, was just beginning to stir from the long slumber of prehistory, taking its first tentative steps, entering a phase of truly rapid social, technological, and cultural development. This era marked the very emergence of early human civilizations, the nascent birth of organized agriculture, the development of sophisticated tool-making, the profound invention of writing systems which allowed for the first tangible, permanent records of human thought and accumulated knowledge, and the foundational formation of large, complex settlements, the precursors to our modern cities. These were moments of profound, accelerating change for our species. Perhaps, as Loeb speculates with a sense of wonder and apprehension, these very events, these burgeoning signs of a nascent intelligence, of developing self-awareness, of technological capability, and of a species beginning to exert its influence on a planetary scale, became the tipping point, the subtle beacon that drew the attention of someone from far, far away, a distant observer across the cosmic gulf, marking Earth as a planet of burgeoning interest. Our nascent signals, our early fires, perhaps reached them. But for what ultimate purpose? This question echoes in the stillness, resonating with both hope and dread. To simply study us, to observe our unfolding story from a cautious distance, to catalog our development without interference, or, more audaciously, to attempt to make contact, to bridge the vast cosmic distances with a message or a presence. Avi Loeb and his colleagues, contemplating the profound implications of such an advanced visitor, believe the true purpose of this object's visit might be far more alarming, far more complex, and potentially far more precarious than it first appears, challenging our inherent optimism about alien encounters. The scientists urge us, with a sober seriousness, not to lose sight of a chilling yet increasingly discussed hypothesis, one known as the dark forest theory. This theory, which initially emerged from the realm of science fiction but has gained traction in serious scientific circles, offers a stark, cold explanation for the cosmic silence we so often perceive. This concept, while popularized in modern science fiction novels, refers back to a famous, almost haunting question posed by the brilliant Italian physicist Enrico Fermi in 1950 during a casual lunchtime discussion on the profound likelihood of extraterrestrial intelligence. He turned to his colleagues and, with a disarmingly simple yet deeply profound query, asked, "Where is everybody?" The essence of his question, deceptively simple, resonates with immense philosophical and scientific weight. Calculations, rigorously grounded in the laws of probability, in the sheer, overwhelming scale of the universe, and in the abundance of potentially habitable exoplanets, strongly suggest that the cosmos should be teeming with intelligent civilizations, that life, in its myriad forms, should be abundant, a cosmic garden. But, if that is truly the case, then why haven't we, despite our increasingly sophisticated instruments, our tireless surveys, and our relentless search across the electromagnetic spectrum, seen any overt, unambiguous signs of them? If life is so common, if intelligence is inevitable, where, indeed, is everybody? This paradox, the Fermi Paradox, is one of the most compelling mysteries of our time. One of the darkest, most profoundly unsettling explanations for this pervasive Fermi paradox is the dark forest hypothesis. It proposes a chilling vision of the universe, suggesting that intelligent civilizations do, in fact, exist in vast numbers throughout the cosmos, but that the vast majority of them are compelled to hide, to remain eternally silent, to camouflage their presence at all costs. They strive, with every fiber of their being, to meticulously conceal their presence, driven by an existential, species-level fear of detection by a more powerful and, crucially, hostile life form. This hypothetical predator, an unseen terror lurking in the cosmic darkness, operating with cold, ruthless logic, is presumed to function under a simple, brutal imperative: to destroy anyone it perceives as a potential threat, a nascent competitor, or to exploit those from whom it can extract valuable resources before they can do the same to it. This is a universe governed by a principle of kill or be killed, a zero-sum game played on a galactic scale. Considering this profound, ultimate danger, other civilizations, in this chilling scenario, go to extreme lengths to remain unnoticed, to disappear into the background noise of the universe, to mimic the silence of the void. They behave precisely as any vulnerable creature in a primeval, predator-filled forest would, risking being devoured, risking total annihilation, if it makes a sound, if it makes a detectable emission, if it dares to reveal its presence to an unseen, potentially hungry hunter. This profound cosmic silence we perceive, then, is not emptiness, not a sign of absence, but rather a universal, existential scream held in check, a galaxy-wide act of collective hiding, a strategic, life-preserving silence. It suggests that the first civilization to announce its presence might be the first to fall. If 3 Atlas, this immense, swiftly moving object with its impossibly precise trajectory, truly is a spacecraft of extraterrestrial origin, an undeniable product of another intelligence, then it is a logical, if sobering assumption that its creators are, by definition, far more technologically advanced than humanity. At the very least, they possess the staggering, almost godlike capability of interstellar travel, a feat that remains, for us, decades if not centuries away. still largely confined to our ambitious dreams and theoretical calculations. And that advanced capability, that mastery of the laws of physics, implies not only extraordinarily advanced propulsion systems far beyond our current understanding of rocket science, but also, disturbingly, the potential for weaponry at a level we have only ever dared to imagine in the most vivid and often terrifying narratives of science fiction, weapons that could reshape planets or extinguish stars. And often terrifying narratives of science fiction, weapons that could reshape planets or extinguish stars. The scale of their technology would be immense, even if this enigmatic visitor is merely an autonomous reconnaissance probe, a sophisticated unmanned scout silently traversing the stars with no living beings aboard, a robotic sentinel of an unseen civilization. The very fact that we may have been detected, that our faint radio signals, our burgeoning technological presence, our planetary biosignatures, or our early nuclear tests have registered on its advanced sensors, raises one of the most profoundly unsettling questions of our era. Do those who discovered us, those who dispatched this silent, colossal observer, harbor friendly intentions, a desire for benevolent contact, for cultural exchange, or for peaceful coexistence? Or, conversely, are we unknowingly facing a threat of becoming prey, a resource to be harvested, a world to be conquered, or a potential competitor to be eliminated by an approaching cosmic predator that watches us from afar, its intentions inscrutable, its power unimaginable, its motivations beyond our current comprehension? These questions hang heavy in the stillness of space and in the quiet, reflective chambers of our minds, shaping our future with their unspoken answers. But what if we were detected even earlier, long before the arrival of 3 Atlas? What if our existence, our unique planetary signature, the subtle emanations of our vibrant, technologically awakening world, was registered not by this colossal, fast-approaching giant, but by another interstellar object, one that briefly graced our solar system 8 years before, acting as a precursor, a faint echo of what was to come? Let us gently rewind the cosmic clock, allowing our thoughts to drift back to the autumn of 2017, a pivotal and deeply intriguing year in our astronomical history. It was then that the powerful Pan-STARRS telescope in Hawaii, a diligent sentinel constantly scanning the vast, dark expanse of the night sky, detected something truly unusual, something that immediately stood out from the predictable, well-understood cosmic ballet of our solar system. It was an object hurtling through our solar system at an incredible, almost bewildering speed. After careful, painstaking trajectory calculations, utilizing the combined efforts of observatories around the world and some of the most sophisticated orbital mechanics software, it became definitively clear that this was no ordinary visitor from within our sun's gravitational embrace. It was the very first unambiguous interstellar visitor ever accurately recorded in human history, a tangible, physical piece of another star system delivered right to our cosmic doorstep, a gift of pure, unprecedented data. The object was named Oumuamua, a name that, as we discussed, embodies the profound essence of a messenger from afar arriving first, in the beautiful, melodic Hawaiian language. This name, carefully chosen, carries the weight of its unique journey and its status as a pioneer. However, it was after its discovery, after the initial excitement had subsided, that Oumuamua truly began to raise the most profound intrigue, spiraling into a vortex of intense scientific debate, speculative theories, and widespread public fascination. By the time it was definitively detected and identified, Oumuamua was already on its rapid departure, already leaving Earth's vicinity behind, vanishing with the same swift, silent grace with which it arrived. This brief, almost teasing encounter deprived scientists of the crucial chance to study it in the kind of sustained, meticulous detail that such an unprecedented object demanded. The observation window was frustratingly short, a mere few weeks. Yet, the small, precious amount of data that was painstakingly collected during its fleeting passage left scientists utterly, delightfully baffled, their conventional models stretched to their limits. Originally, this foreign object was provisionally considered to be a comet, a classification that, on the surface, seemed the most natural and parsimonious fit for a transient visitor with a highly eccentric, unbound orbit. Comets, after all, are known for their long, looping journeys into the inner solar system from its distant fringes. But that comfortable, familiar explanation began to crumble, slowly but inexorably, as more detailed information and refined observations emerged from the observational data. Firstly, and most strikingly, it completely lacked a visible tail. This was a critical and almost unheard of absence. For a comet, as it approaches the Sun and its icy surface is warmed by the intense solar radiation, typically undergoes a process called outgassing. The frozen volatiles on its surface, such as water ice, carbon dioxide, and other gases, sublimate directly into vapor, expanding rapidly and ejecting dust and gas into the surrounding space. These emissions, illuminated by the Sun's radiant energy, then coalesce to form the characteristic bright, luminous tail or coma that streams dramatically behind the comet's nucleus, a brilliant reflection of sunlight against the cosmic canvas. Oumuamua, defying all astronomical expectations, sailed past our Sun without leaving any such fiery, gaseous signature, a silent, unblinking ghost in the solar wind, devoid of the expected theatrical display. This was a profound, unexplained anomaly. Secondly, and perhaps even more perplexing to the scientific community, Oumuamua suddenly and inexplicably accelerated, subtly but definitively changing its trajectory in a way that could not be accounted for by the Sun's gravity alone. This phenomenon, known as non-gravitational acceleration, is often observed with comets, caused by the subtle thrust generated by these very same evaporating materials, acting like tiny natural rocket jets, providing a gentle push. Yet, again, in the case of Oumuamua, and this was the crux of the puzzle, no traces of this crucial outgassing, no telltale coma or tail, were detected by any instrument. This presented a profound paradox, an object accelerating as if propelled by powerful jets, yet showing absolutely no visible evidence of such propulsion, no visible effluvia. This was a fundamental contradiction that demanded explanation beyond conventional cometary physics. Add to these unexplained phenomena the utterly unusual and highly debated shape of Oumuamua. According to various estimates, derived from the way its brightness varied as it tumbled erratically through space, it was initially thought to be remarkably elongated, perhaps akin to a colossal, slender cigar, tumbling end over end. However, according to later, more refined analyses and interpretations of its light curve, it might have been strikingly flat and disc-shaped, like a cosmic pancake or a broad, thin shard. Both of these proposed forms are profoundly unlike any other known natural space object in our solar system, challenging our conventional understanding of natural celestial mechanics and the formation processes of asteroids and comets. Given all these inexplicable characteristics and behaviors related to Oumuamua, its non-gravitational acceleration without outgassing, and its bizarre shape, it is hardly surprising, indeed almost inevitable, that some scientists, driven by the purest form of scientific inquiry and a willingness to explore the edges of possibility, were led to propose the audacious hypothesis of its artificial origin. The natural explanations, while attempting to explain individual anomalies, struggled to account for the totality of its strange behavior. And now, as we observe the unfolding drama of 3 Atlas, this colossal, swift-moving object, we may even have compelling grounds to suspect that Oumuamua, that enigmatic precursor, that messenger from afar, might be intimately connected to the approaching giant. Just like Oumuamua, this new object, 3 Atlas, also appears to lack a significantly visible, flamboyant cometary tail in its initial, distant observations, further deepening the sense of shared mystery and unconventional behavior. Furthermore, it exhibits an incredibly unusual trajectory, one that, as we've discussed, appears far too precise and deliberate for random chance, echoing Oumuamua's own perplexing path. The sheer scale of these 2 objects also makes for an intriguing and potentially revelatory comparison, a contrast that might hint at a deeper purpose. According to preliminary data, Oumuamua was estimated to be about 377 feet long and 364 feet wide, roughly the size of a standard American football field. This makes it, if one were to imagine a deliberate, intelligent design, an ideal candidate for a reconnaissance probe, small, incredibly fast, and therefore exceedingly difficult to detect or track with sustained precision, a perfect scout. The scale of 3 Atlas, however, operates on an entirely different magnitude. It is, by all preliminary estimates, literally hundreds of times larger than Oumuamua, an object comparable in size to a small, sprawling city. Drawing an analogy between these 2 interstellar visitors, one might be left with the distinct, almost chilling impression that Oumuamua might indeed have been a scout, a small, nimble messenger dispatched ahead to assess the cosmic situation, to, quote, test the waters around our star system, to gather initial intelligence. And 3 Atlas, the immense, deliberate presence now approaching, could be the main vessel, perhaps even a mothership or a follow-up expedition, a more significant deployment, silently following in its wake, poised to complete a mission initiated long, long ago with a broader, more impactful objective. The implications of such a connection, while speculative, are profound. Avi Loeb, now the most prominent and vocal proponent of the extraordinary idea that the object heading towards us is a definitively artificial spacecraft, first articulated a strikingly similar idea about Oumuamua back in 2017. Immediately after Oumuamua's sudden and puzzling arrival in our solar system, a moment of cosmic serendipity, Loeb was among the very first to courageously and publicly suggest the possibility of its artificial origin. This was a bold move, as it challenged the conventional wisdom and risked professional skepticism. While the majority of scientists diligently, and quite reasonably within the framework of existing knowledge, attempted to find natural, conventional explanations for the object's strange and unprecedented behavior, meticulously searching through known cometary and asteroidal phenomena, Loeb stood almost alone, steadfastly defending his unconventional, yet rigorously argued, hypothesis. He presented his case with scientific papers and public discussions, unafraid to explore possibilities that stretched beyond the established paradigms. Over time, however, a consensus slowly began to coalesce within the broader scientific community regarding Oumuamua's true nature. The prevailing view eventually concluded that Oumuamua was, most likely, an unorthodox comet, a peculiar variant unlike any seen before, a member of a rare class of interstellar comets. Its strange and highly unusual shape, whether initially envisioned as elongated like a cigar or later as flattened and disc-shaped like a cosmic pancake, is now largely attributed to the inherent limitations of our distant observational abilities, a consequence of trying to discern the precise geometry of a tiny tumbling object from millions of miles away with limited resolution. Perhaps the consensus suggests these highly elongated or flattened shapes are not as rare in the vast, unexplored reaches of interstellar space as we once assumed. We simply haven't had the opportune chance to observe them up close, to characterize them fully, until this unique visitor appeared. Our sample size of interstellar objects is, after all, still incredibly small. The mysterious, non-gravitational acceleration of the object, which generated so much intense debate and fueled so many speculative theories about its propulsion, was also eventually explained, or at least provided with a plausible, naturalistic explanation that fit within the cometary model. Similar to the behavior of many other comets, this acceleration, it was theorized, may indeed have been caused by subtle gas emissions from the object's surface. The key difference, however, was proposed to be in its composition. Unlike typical comets, which have abundant dust mixed with their ice, Oumuamua likely contained very little dust. Therefore, its gas tail, formed by these emissions, would have been nearly invisible, a phantom exhalation to our instruments, thus resolving the paradox of acceleration without a visible coma or tail. Recent research, for example, has suggested that Oumuamua's acceleration could be explained by the release of entrapped molecular hydrogen formed by cosmic ray processing of water-rich ice while in interstellar space, a subtle fuelless jet. Another prominent theory posits it was made of nitrogen ice, similar to the vast icy plains found on Pluto's surface, which sublimated under solar heat, providing thrust without a visible dust trail, a kind of cosmic dry ice. These natural explanations, while still somewhat exotic, provide a more conventional framework for understanding Oumuamua. But now, our focus shifts back, with a sense of quiet urgency, to the present, to the immense, swiftly moving object designated 3 Atlas. With all the preceding context of Oumuamua's mysteries and its eventual naturalistic explanations, we must again ask the crucial questions. What about 3 Atlas? Does this new, colossal visitor, with its even more baffling trajectory and its sheer, overwhelming scale, truly pose a threat to us, or is it, too, merely another fascinating, albeit extraordinary, piece of the cosmic puzzle, a natural phenomenon pushing the boundaries of what we thought possible? Most scientists, weighing the available evidence from the initial and ongoing observations, largely agree that Avi Loeb's and his colleagues' assumptions about the object being artificial, while provocative and immensely stimulating for intellectual discourse, are fundamentally incorrect. The prevailing consensus among astrophysicists is that what is rapidly approaching us is nothing more and nothing less than a truly massive, yet entirely natural comet, albeit one with some unique characteristics. And they articulate a number of compelling reasons that underpin this conclusion, drawing on both new observational data and established astronomical principles, meticulously applying the scientific method to this unprecedented event. Firstly, the assertion made by Loeb and some others about the comet entirely lacking a dust tail, a crucial absence for the artificial hypothesis, does not, in fact, fully align with more recent and higher resolution observations. For instance, in very recent photographic captures and spectroscopic analyses, a faint, ethereal glow can be discerned surrounding the comet's nucleus. This faint luminescence is, in all likelihood, the very nascent coma, a cloud of gas, ice, and dust that typically forms around every comet as it nears the sun and begins to warm, a process of gradual sublimation. Its current intensity is undeniably weak, a delicate veil against the darkness of space, perhaps due to its initial distance or specific composition, but it is expected to grow progressively brighter and significantly larger as 3 Atlas continues its inexorable approach toward our star, shedding more volatile materials and reflecting more sunlight. Moreover, the object's intrinsic brightness, even at a great distance where it would normally be a faint speck, also strongly indicates that we are most likely dealing with a comet exceptionally rich in ice. Since ice, by its very nature, reflects sunlight remarkably well, even more efficiently than rock, the object appears luminous and distinct even from millions of miles away, an indication of its icy composition, which is characteristic of comets. To illustrate this more clearly, imagine, if you will, looking at a visual representation. On the left, you'll see a meticulously assembled collage of images taken in different spectral bands, revealing various chemical signatures and light wavelengths. These images track the object's subtle movement against the unchanging stellar background, clearly visible along with its intense, almost dazzling brightness, which speaks to its reflective, icy nature. And, crucially, on the right side of this visual, perhaps subtly, you can spot a faint but undeniably noticeable dust tail, a shimmering ethereal wispy structure. This tail, though not as dramatic as some famous comets, serves as empirical evidence, a clear signature of outgassing and sublimation, supporting the conclusion that 3 Atlas is indeed a comet. This is direct observational data that counters some of the initial claims of a complete lack of cometary activity. But then, what about its mysterious, almost impossibly precise trajectory? The one estimated to have just a 0.005% chance of occurring randomly. This remains a significant puzzle, a tantalizing anomaly that even those who strongly favor a natural explanation cannot definitively dismiss or easily explain away. The trajectory of 3 Atlas is, without question, truly unique, a cosmic ballet performed with an almost unsettling precision. It allows the object to pass relatively close to 4 distinct planets in our solar system, a truly impressive series of near misses and gravitational interactions. And yet, paradoxically, it does not provide an optimal close-up opportunity for Earth-based observers to scrutinize our own planet in detail. It seems to keep us at a certain distance. At its closest approach to Earth, 3 Atlas will be approximately 167 million miles away. This distance is almost twice the average distance between Earth and the Sun, a considerable cosmic gap, keeping it well outside the comfortable observational range we might hope for. This fact naturally begs a logical and fundamental question, one that even the proponents of a natural origin must grapple with. If the object's ultimate goal, if it truly possessed one, was to study humanity, to gather intimate details about our civilization, why would it come so close, traversing interstellar space, yet remain so frustratingly far out of immediate, detailed reach? Why would it not choose a trajectory that brings it significantly closer, perhaps a trajectory that takes it past our moon, for example, offering a far more intimate, high-resolution glimpse of our world and our technological signatures? What indeed would be the strategic point of crossing the unfathomable distances of interstellar space only to maintain the status of a distant, obscured observer, forever just beyond our grasp, almost as if by design? This remains a powerful argument for those who lean towards an artificial explanation, highlighting the unusual nature of its path. Samantha Lawler, a distinguished astronomer at the University of Regina in Canada, who specializes in the complex dynamics of solar system objects and the intricate ballet of celestial mechanics, asserts with confidence that all the available data, when interpreted through the lens of conventional astronomy and statistical probability, strongly indicate that this is nothing more and nothing less than an ordinary comet. It is, in her professional estimation, a comet that has been ejected from another solar system, embarking on a solitary, endless journey through the galaxy, a cosmic wanderer, just like countless billions of comets that have been ejected from our own solar system over cosmic eons. such ejections are a natural, albeit often dramatic, part of planetary system formation and evolution. The sheer size of 3 Atlas, while undeniably impressive and certainly larger than Oumuamua, is also, she contends, not particularly extraordinary in the grand scheme of cosmic wanderers. At first glance, an object with an estimated diameter of 6 to 9 miles may indeed seem very large, even monumental, capturing the imagination, but it is crucial to keep in mind that we are dealing with a space object, a fragment of a vast, ancient, and often colossal universe. For a more grounded perspective, consider the famous Hale-Bopp comet, which captivated skywatchers worldwide in 1997 with its spectacular naked-eye visibility and its immense tail. That magnificent celestial visitor had a nucleus with a diameter of about 46 miles, significantly larger than 3 Atlas. Then there is the truly colossal Bernardinelli-Bernstein comet, discovered as recently as 2021, which boasts an astonishing diameter of approximately 85 miles across, making it arguably the largest comet ever observed by humanity. So despite its undeniably impressive dimensions, 3 Atlas is far from being the largest known comet. Its size, while noteworthy, is not an outlier when compared to the largest comets, and therefore cannot be definitively considered, with any degree of scientific certainty, as irrefutable evidence of an artificial, technological origin. Its dimensions fall within the known, albeit upper, range for comets. Virtually the entire scientific community, therefore, is now confident in their assessment that 3 Atlas is, unequivocally, a comet. And not just any comet, but a rare and exceptionally valuable one, a pristine relic from another star system, offering an unprecedented opportunity for study. Its official designation, 3I/Atlas, is rich with scientific significance and tells a concise story of its identity. Named after the Atlas telescope system that first detected the object, the Atlas part acknowledges the instrument and the diligent team behind the discovery. The letter I stands, profoundly, for interstellar, unequivocally indicating its origin from beyond the boundaries of our own solar system, a true traveler from another star. And the number 3 signifies a critical detail in our evolving understanding of the cosmos. That this is only the 3rd confirmed interstellar object ever accurately recorded and meticulously tracked by humanity, making each such visitor an extraordinary event. The first, as we have explored, was the enigmatic Oumuamua, discovered in that pivotal year of 2017, a perplexing object that defied easy categorization and sparked intense debate. The second was the comet 2I Borisov, a more traditional comet with a clear coma and tail, which made its appearance and was discovered on August the 30th, 2019, confirming that not all interstellar visitors would be as enigmatic as Oumuamua. And now there is 3I/Atlas. As we can clearly see, such celestial visitors are exceedingly rare, precious glimpses into the unfathomable depths of the universe, each a unique scientific treasure. Every single opportunity to study them, to analyze their composition, their trajectory, and their behavior, is a unique window into distant corners of the universe, regions that remain, for now, utterly inaccessible to our most advanced space probes. These objects bring a piece of another star system directly to our observational doorstep. Right now, as you listen, 3 Atlas is rapidly approaching the Sun, accelerating further, and scientists worldwide have been granted a rare, albeit brief, chance to observe it up close, to gather invaluable data as it passes through our inner solar system. This observational window, though short and finite, may offer crucial clues, definitive answers, about the object's true nature, while it remains within our telescopic view, before it too, like Oumuamua, recedes into the interstellar dark, a silent departure. But as we patiently await a final, conclusive answer to the profound question of what 3 Atlas truly is, as we process the implications of its approach, is it worth taking a moment to gently rewind the cosmic clock back to that pivotal year of 2017? That was the year when Oumuamua, the very first recorded interstellar object, silently, swiftly passed through our solar system, becoming a cosmic landmark. And while with 3 Atlas we have the immense fortune of a longer lead time, a period of anticipation, a chance to observe everything in, or close to, real time to prepare for its approach, in the case of Oumuamua, we never had that invaluable opportunity. It flashed past us, an ephemeral ghost, leaving behind far more questions than definitive answers, a truly frustrating cosmic enigma. But the scientific community, ever persistent, ever driven by the insatiable desire for knowledge, is not yet ready to let Oumuamua's mysteries vanish into the endless night. They have boldly proposed a large-scale, ambitious mission, a truly audacious endeavor dubbed Project Lyra. Its challenging yet inspiring goal, to dispatch a spacecraft across unimaginable distances, to literally intercept Oumuamua, to catch up with it, to get close enough, finally, to determine once and for all what this elusive messenger from afar truly is. This is not just a mission, but a testament to human ingenuity and cosmic curiosity. Immediately following the initial, startling discovery of Oumuamua, a profound wave of palpable excitement, tinged with a delicious scientific bewilderment and a touch of professional anxiety, swept through the global scientific community. This object simply refused to fit neatly into any known astronomical category. It defied easy classification, challenging decades of accumulated knowledge about celestial mechanics. No one, not even the most seasoned astronomers, could confidently articulate what exactly we had encountered, or how to explain its bizarre, anomalous behavior. It challenged, fundamentally, everything we thought we knew about the typical inhabitants of space, pushing the boundaries of our cosmic understanding, forcing a re-evaluation of our models. Astronomers around the world, recognizing the unprecedented and fleeting nature of the discovery, urgently repurposed their most powerful telescopes, even canceling their ongoing, long-planned research projects, all in a desperate race against time to catch a few more fleeting signals, a few more precious data points, from it before it vanished forever, into the impenetrable darkness of interstellar space, becoming an uncatchable enigma. Initial estimates, derived shortly after its discovery and based on its fluctuating brightness as it tumbled, suggested that Oumuamua was remarkably elongated, perhaps about 300 feet long and a mere 130 feet wide, resembling a colossal, slender cigar, tumbling end over end through the void. This extreme cigar-like shape was profoundly unlike any known natural celestial body in our own solar system, instantly marking it as a profound anomaly, a shape that whispered of artificiality. But later, as new, refined data arrived from further observations and more sophisticated analytical models were applied to its light curve, scientists at McMaster University in Canada made their own detailed calculations, refining the earlier estimates. These new analyses suggested that its dimensions might have been somewhat different, perhaps around 380 feet in length, 364 feet wide, and a comparatively slim 62 feet thick. This revised understanding of its dimensions implied a shape that was not so much an elongated cigar, but rather flatter, more akin to a cosmic pancake, or a broad, thin shard, almost disc-like in its proportions. Yet, even this revised, flattened shape remains exceptionally unusual for natural space objects. Similar proportions, those that deviate so dramatically from spherical or slightly irregular bodies, have only ever been observed in exceedingly rare, exotic cases, such as Arakoth, formerly Ultima Thule, a peculiar celestial body residing deep within the Kuiper Belt, far beyond Neptune's orbit, which was famously visited by NASA's New Horizons spacecraft. Arakoth, however, is a contact binary, two lobes gently fused together, which is a different formation mechanism. Even with such rare exceptions, Oumuamua's shape, regardless of its exact geometry, did not make it any less mysterious. Its form continues to be regarded as extremely atypical, a fundamental puzzle that continues to raise profound questions about its origin, its formation processes, and its possible nature beyond conventional astronomy. We were, and still are in retrospect, observing something truly unusual and profoundly mysterious, an object hurtling through the vacuum of space at an incredible, almost terrifying speed of approximately 16 miles per second. To put that into perspective, that is faster than Voyager 1, one of the fastest spacecraft ever launched by human hands, a testament to our technological prowess, but also a measure of Oumuamua's extraordinary velocity. At such an astounding speed, Oumuamua could effortlessly traverse the distance between the vibrant heart of New York City and the sprawling expanse of San Francisco on the West Coast in a mere 2 minutes and 38 seconds. This phenomenal velocity, far exceeding the escape velocity for objects gravitationally bound to our Sun, was the initial, unequivocal indication that the object was not, and never had been, a permanent resident of our solar system. It was a clear signature of its interstellar provenance, and soon, this powerful suspicion was confirmed by meticulous orbital calculations. It was a distant, ephemeral interstellar visitor, but the profound question remained, hauntingly, stubbornly unanswered, echoing in the quiet chambers of scientific inquiry. Where exactly had it come from? What distant star system had cast it forth? And more importantly, what, precisely, was it? These questions burned brightly. The very first thing astronomers, armed with their knowledge of cometary behavior and their experience with solar system objects, expected to see, as they meticulously observed, the rapidly receding object was a bright, shimmering tail of gas and dust. After all, they initially assumed it was a comet, and comets behave with a predictable, almost theatrical flair when they approach the Sun and are warmed by its radiation. Under the relentless influence of solar heat, the volatile ices and frozen gases locked within their surfaces begin to sublimate, to evaporate directly into a gaseous state, expanding rapidly and ejecting dust and gas into the surrounding space. These emissions, illuminated by the Sun's radiant energy, then coalesce to form the characteristic bright, luminous tail or coma that streams dramatically behind the comet's nucleus, a brilliant reflection of sunlight against the cosmic canvas. A vivid and unforgettable example of this breathtaking phenomenon is the aforementioned comet Hale-Bopp, whose magnificent, sweeping tail was clearly visible to the naked eye from Earth throughout much of 1997, a spectacle that captured the imaginations of millions. A true cosmic show. But Oumuamua, with an almost defiant disregard for our expectations, for our established scientific models, shattered all such conventional predictions. It flew past the Sun, reaching its closest point without leaving any discernible trace of evaporation. No gas, no dust, not even the faintest, most ethereal hint of a tail. Its behavior, utterly devoid of the expected cometary theatrics, broke all the established rules that apply to ordinary comets within our solar system. This mysterious, silent guest, continued to baffle and intrigue the world of science, becoming a source of intense academic debate. Its highly unusual shape, its hyperbolic, unbound trajectory, and its incredible, unwavering speed all pointed, with an insistent clarity, to one profound conclusion. We were dealing with something completely unique, something fundamentally unlike any object previously known, categorized, or even theorized by humanity. It was an object that forced us to re-evaluate our cosmic vocabulary. Tension, a quiet hum of intellectual unease and intense curiosity, continued to grow in the scientific community. The main question, the burning inquiry that occupied countless hours of discussion and debate, was, and to some extent still is Oumuamua just an ordinary, albeit unusually strange, cosmic body, a rare specimen of interstellar debris, or have we, for the very first time in our history, encountered tangible evidence of extraterrestrial technology, a deliberate artifact from another civilization? This was a question that divided opinions, fueling impassioned debates among the brightest minds, forcing scientists to confront the profound implications of their own data. But the strangest part, the most profoundly perplexing twist in Oumuamua's narrative, was yet to come. A revelation that further deepened its enigma and propelled it into the realm of the truly inexplicable. It turned out, through meticulous reanalysis of its trajectory data, that Oumuamua had unexpectedly accelerated. And not just accelerated in a minor, predictable fashion, a subtle tweak in its speed, but had done so in a way that defied conventional understanding, as if it were following its own hidden, predetermined plan, a purposeful maneuver in the cosmic dance. Scientists determined that approximately 40 days before its discovery by pan-stars, the object had passed dangerously close to the Sun, a mere 23 million miles from its searing surface. This was its perihelion, its closest approach to our star. And it was precisely after this moment of intense solar proximity that it suddenly, mysteriously, gained speed. At its peak, Oumuamua accelerated to an astonishing 54 miles per second, a velocity 3.5 times faster than it had been traveling before its close flyby of the Sun. This was a profound and inexplicable boost. That speed, 54 miles per second, is truly astonishing, a testament to immense, unseen forces. It was, for instance, 5 times faster than our venerable Voyager 1 spacecraft is currently traveling, a probe launched decades ago that is now at the very edge of interstellar space, one of humanity's fastest creations. It was 11 times faster than the powerful Starship rocket, a pinnacle of modern human engineering, designed for interplanetary travel. And almost inconceivably, it was 250 times faster than the speed of sound here on Earth, demonstrating an almost supernatural velocity. This kind of sudden, powerful acceleration is typically observed in comets when powerful jets of dust and water vapor expelled from their heated surfaces provide them with an additional, non-gravitational boost, acting like tiny, natural thrusters. However, as we have already emphasized, and this was the enduring paradox, Oumuamua showed absolutely no signs of such activity. No visible coma, no tail, no discernible jets of gas or dust, no signature of traditional cometary outgassing. Something, some unseen, unidentifiable force, had accelerated it. But the profound question remained, hauntingly, stubbornly unanswered. What, exactly, was it? A whisper began to circulate, initially tentative, a quiet suggestion among those brave enough to challenge dogma, then gaining momentum in the scientific discourse. Oumuamua. A spaceship? What if this object, this silent, swift wanderer, wasn't what it initially seemed to be? What if, 8 years ago, something far more intriguing, far more consequential than a mere chunk of space ice or rock flew so tantalizingly close to Earth. Perhaps, the audacious thought emerged, it was a sophisticated spacecraft, meticulously engineered and crafted by another, unseen civilization, a silent probe designed for exploration. This is the very hypothesis that was put forward, with compelling arguments and meticulous calculations, in 2021 by the renowned astronomer Avi Loeb, who at the time chaired Harvard University's prestigious astronomy department, collaborating with his astute colleague Shmuel Bialy. They boldly proposed that the first detected interstellar object, Oumuamua, may well have been a space probe, an artificial device designed for exploration, a product of advanced engineering rather than natural forces. The researchers were and remain convinced that Oumuamua's utterly strange and unprecedented behavior, particularly its non-gravitational acceleration without any visible outgassing, provided every substantial reason to suspect that it might be something truly unorthodox, something beyond the realm of natural cosmic phenomena, something that cried out for a non-natural explanation. What most profoundly intrigued these scientists, what truly captured their investigative focus and fueled their hypothesis, was that specific moment when the object unexpectedly and smoothly accelerated during its close pass by the Sun. Certainly, the Sun's immense gravity could provide a significant gravitational slingshot effect, imparting a substantial boost in speed to any object. However, based on meticulous calculations, that particular component of acceleration, the purely solar gravitational push, should have been considerably weaker, or at least different in its characteristic, than what was actually observed. It was this discrepancy, this unexplained excess acceleration, that led Avi Loeb and Shmuel Bialy to propose their groundbreaking, if controversial, hypothesis. What if, they posited, this wasn't just a barren, tumbling rock from another star system, but rather an object ingeniously utilizing a sophisticated form of light sail technology? At first glance, the idea undoubtedly sounds fantastical, drawn from the imaginative pages of visionary science fiction. However, it is fundamentally based on established principles of real physics well understood within our own engineering. A light sail is conceived as an incredibly thin and lightweight structure, designed with an expansive, highly reflective surface area that can harness the subtle yet persistent pressure exerted by light, specifically streams of photons. These photons, emanating from a star like our Sun, for example, exert a tiny but constant pressure on the surface of such a sail. Over time, this constant push can gradually, but continuously, accelerate the sail to incredibly high velocities without the need for traditional, fuel-intensive chemical propulsion systems. It is a form of propulsion using the abundant, free energy of starlight. If Oumuamua had indeed possessed such an ultra-thin, highly reflective structure, a massive light sail capable of efficiently catching and utilizing solar radiation pressure, then the intense solar wind and the sheer photon flux from our Sun, particularly during its close perihelion passage, could have provided it with precisely the extra push needed to account for its observed non-gravitational acceleration. This would explain acceleration without any visible outgassing. According to Loeb and Bialy's calculations, for this to be a plausible mechanism, the sail's thickness would need to be remarkably fine, perhaps just 0.3 to 0.9 millimeters, a thickness comparable to that of a single human hair. Just imagine, for a moment, an object potentially 380 feet long, yet less than a millimeter thick, a vast, almost ethereal sheet of advanced material drifting through the void, catching the light like a cosmic feather. The surface area to mass ratio would be extreme, Such a concept might sound wildly unrealistic, utterly beyond our current technological capabilities, but the foundational principles of light sail technology already exist, and have even been successfully tested by humanity. For example, it was pioneered and tested by the Japanese spacecraft Icaros, interplanetary kitecraft accelerated by radiation of the Sun, launched in 2010. Icaros became the world's first probe to successfully use solar radiation pressure as its sole primary propulsion source, demonstrating its viability by successfully journeying toward Venus. It unfurled a square sail, 14 meters, 46 feet, on a side, made of a very thin polyamide material. Perhaps then, Oumuamua was something akin to that, an object equipped with a sophisticated solar sail, meticulously designed to accelerate and subtly change course as it passed by various star systems, harvesting their light for propulsion and navigation. And if it truly was an artificially created device, a product of advanced engineering, it's entirely plausible that, in addition to such a sail, it possessed other technological components, advanced systems that we can only speculate about for now. But one thing seems inherently obvious. An object of this nature, if artificial, would almost certainly require at least a sophisticated system for scanning and understanding its surroundings, perhaps optical sensors, spectrometers, or magnetometers, and a means of communication, either to transmit valuable data back to its creators across light years, or to receive new instructions from them across the vastness of interstellar space, adapting its mission as it traveled. Avi Loeb also diligently conducted calculations to determine whether Oumuamua's hypothetical light sail, if it indeed existed, could withstand the rigors of an incredibly long interstellar journey. They considered the brutal realities of the cosmic environment, the density of interstellar gas and dust, however tenuous, and the immense speeds at which the object would inevitably collide with these microscopic particles in the galactic medium, each impact acting like a tiny, high-velocity projectile. They modeled the effects of erosion, radiation damage, and the structural integrity required. The results of their simulations were, in fact, quite impressive and supportive of their hypothesis. If Oumuamua really was a device like the one they envisioned, a resilient, intelligently designed light sail, it could conceivably have traveled at least 16,000 light-years from its home star system, crossing vast swaths of the Milky Way, enduring countless eons, all while remaining structurally intact and fully functional, a testament to its advanced construction. That said, the scientists themselves, with characteristic academic caution, do not definitively or dogmatically claim that Oumuamua is a spacecraft. Rather, they humbly yet firmly believe that the possibility exists, that it is a serious enough hypothesis, supported by enough anomalous data and theoretical plausibility, that it should not be summarily dismissed or casually ignored in scientific discourse, simply because it challenges our current understanding. Science, after all, thrives on questioning accepted paradigms, exploring the outer edges of possibility, and following the data wherever it leads, even if it leads to uncomfortable or extraordinary conclusions. The scientific process demands open-mindedness to new possibilities, even those that seem outlandish at first glance. If we allow ourselves, for a moment, to assume that Oumuamua truly was an artificial object, a product of design rather than random cosmic chance, the idea of a solar sail, while compelling, is just one possible interpretation, one version of its technological nature. It might have been a far more complex and advanced probe, a sophisticated, active unmanned spacecraft, perhaps powered by miniature nuclear systems or advanced fusion engines, intentionally dispatched to thoroughly study our solar system, much like our own intrepid Voyager probes, but on an interstellar scale. Its mission parameters could have been incredibly sophisticated, its sensors finely tuned for life detection. And there are compelling reasons to believe that if it was indeed a ship, a vessel of exploration, it was almost certainly unmanned. Consider the sheer scale of the journey. Oumuamua's observed speed, while immense by human standards, would still mean it would take roughly 11,000 to 11,500 years to traverse a single light year. Now, compare that to the distance to the nearest star, Proxima Centauri, which is just over 4 light-years away. That would imply that the trip from a hypothetical origin near Proxima Centauri to our solar system would have taken Oumuamua an astounding 44,000 to 46,000 years. And if it came from farther, say 16,000 light-years away as Loeb's calculations suggested, the journey would have spanned tens of millions of years. Such incredibly long journeys, lasting tens of thousands or even millions of years, are simply impossible for any known form of living, biological organism, at least within the parameters of our current understanding of biological endurance, interstellar radiation exposure, and the sheer challenge of maintaining life support. This powerfully suggests that if this was indeed a ship, it was most likely controlled remotely, either by a sophisticated autonomous program, a self-repairing artificial intelligence capable of operating for millennia, or by an intelligence communicating with it from an unimaginable distance, perhaps from a home system that itself has long since passed into history. However, it is crucial to acknowledge that not everyone within the scientific community shares this audacious point of view, or Avi Loeb's interpretation of the data. Many highly respected scientists consider the idea of Oumuamua being a possible spacecraft or artificial object to be overly speculative, a leap of faith not yet supported by sufficient direct, irrefutable evidence. In their considered opinion, while the anomalies are intriguing, there simply isn't enough undeniable empirical proof, strong enough to withstand the rigor of scientific skepticism, to support such bold, transformative claims that would fundamentally redefine our understanding of the universe. The default scientific position, they argue, must always favor natural explanations until the evidence for an artificial one becomes overwhelming. Scientists Alan Jackson and Steve Desch from Arizona State University, for example, proposed their own alternative hypothesis regarding the enigmatic nature of Oumuamua, a detailed and scientifically grounded explanation that attempted to account for all the observed anomalies within a natural framework. They suggested it may have been a fragment of frozen nitrogen. This type of substance, in vast, sprawling quantities, can be found, for example, on the dwarf planet Pluto. When our New Horizons spacecraft flew past Pluto in 2015, it observed immense, glistening, icy plains, such as Sputnik Planitia, vast lakes of frozen nitrogen stretching across its surface. The researchers proposed that a powerful impact event, perhaps a catastrophic collision with another celestial body in a distant star system, could have broken off a sizable chunk of such a nitrogen-rich surface from a Pluto-like exoplanet. This fragment, once dislodged, would then have been violently ejected into interstellar space, embarking on its lonely, eons-long journey across the galaxy. As it approached our sun, they theorized, the nitrogen ice, being highly volatile even at moderate temperatures, would have begun to rapidly sublimate and evaporate from the heat, creating a powerful, directional jet propulsion, a natural thruster that could plausibly explain the object's sudden and inexplicable acceleration without a visible dust tail. Furthermore, the theory suggests that as the nitrogen ice sublimated, it would have done so from all sides, eventually causing the object to become thinner, more pancake-shaped, which aligns with later shape estimates for Oumuamua. This theory, while complex, offers a comprehensive natural explanation. Meanwhile, two other astute scientists, Daryl Seligman of Cornell University and Jennifer Bergner of the University of California, Berkeley, have offered their own compelling explanation for this mysterious object's behavior, focusing on a different type of ice. According to their hypothesis, Oumuamua was once an ordinary water-rich comet, orbiting a distant star, much like the comets that orbit our own sun. But at some point in its long history, perhaps due to a close gravitational encounter or a violent ejection, it was violently cast out from its home system into the vast, cold emptiness of interstellar space. During its incredibly long and arduous journey through the galaxy, spanning millions of years, it was exposed to powerful cosmic rays, high-energy particles, emanating, for example, from distant supernova explosions or other energetic cosmic events. These relentless cosmic rays, they propose, could have chemically transformed up to a third of its deep-seated water ice into molecular hydrogen, which then became trapped, like tiny gas bubbles, within the remaining ice matrix, unable to easily escape. Later, when Oumuamua finally reached our sun and warmed up, the accumulated hydrogen molecules, now free to expand and sublimate, would have started to escape, like countless tiny jet streams, from within the object's interior. This hydrogen outgassing, they suggest, is what provided the object with its mysterious extra push, its non-gravitational acceleration. The unusual behavior, such as the striking lack of a bright, visible tail like typical comets, is elegantly explained by the fact that light hydrogen gas, unlike heavier dust particles, wouldn't generate enough thrust to carry much dust with it, rendering any tail effectively invisible to our instruments. As a result, we would observe strong acceleration without any visible trail of dust or gas, a perfect, natural resolution to the paradox that so vexed early observers. Other scientists also share similar yet subtly different ideas to explain this puzzling object, each attempting to fit the pieces of the cosmic puzzle together within a naturalistic framework. Some even gravitate toward even simpler hypotheses, seeking the most parsimonious explanation, the one that requires the fewest new assumptions. Karen Meach, an astronomer at the University of Hawaii at Manoa, for example, believes that Oumuamua is simply a very ordinary comet, albeit one with an unusually low dust content, a dry comet in a sense, which would naturally account for the perplexing lack of a visible tail. Perhaps its formation environment was simply dust-poor. And as for the unusual shape of Oumuamua, whether cigar-like or pancake-like, perhaps, she suggests, it's not so rare at all in the broader galaxy. The fact that it seems atypical to us may simply reflect our inherently limited experience, our relatively short time studying interstellar objects. The universe, after all, contains a truly vast and astonishing diversity of forms and structures, many of which remain unseen and unimagined. A cigar-shaped or disc-shaped object might, in reality, be much more common than we think, a statistical norm in the wider galaxy. Most of them are likely just too far away, too faint, or too brief in their passage for us to ever observe them with our current technology, remaining forever in the realm of the theoretical. Although the majority of the scientific community now generally agrees that Oumuamua is most likely a natural cosmic body, either a particularly unusual comet or an asteroid, a fragment of another stellar system, we still, even now, have no definitive, irrefutable, direct confirmation of this. The debate, though leaning heavily towards natural explanations, is not entirely closed. which means the central, tantalizing question remains wide open, a persistent echo in the quiet corners of scientific thought, a challenge to our certainty. How can we ever truly know with absolute certainty what this mysterious, fleeting interstellar visitor really was, given its swift departure and the inherent limitations of our initial, distant observations? The cosmic stage has shown us a brief, enigmatic performance, but the true nature of the actor remains shrouded. This profound uncertainty, this lingering mystery, this unyielding desire for definitive answers, gives rise to a truly bold and imaginative endeavor, a mission to physically catch up with Oumuamua. The challenge is immense, almost impossibly daunting, stretching the very limits of human engineering and ambition. It is, quite simply, impossible to see or discern Oumuamua now, even through the most powerful space telescopes we possess today, as the object is rapidly moving away from us at immense speed and is extraordinarily small, almost incomprehensibly tiny. Its estimated average diameter is about 110 meters, 360 feet, making it roughly 3.5 times shorter than the iconic height of the Empire State Building, a mere speck in the cosmic ocean. Trying to spot such a minuscule, dark, unlit object at a distance of billions of miles, already beyond the orbit of Neptune, would be akin to attempting to spot gathering its last faint glimmers of light before it completely faded into the crushing darkness of interstellar space. A ghost swallowed by the cosmic night, seemingly gone forever. But what if, instead of merely watching it recede, we were to attempt the seemingly impossible, to catch up with this object and study it up close, to unravel its secrets with direct, in-situ observation, to touch a piece of another star? The very idea, while undeniably sounding audacious, almost impossibly challenging, a venture into the unknown, is precisely the monumental challenge that a group of determined scientists and engineers, driven by an insatiable thirst for knowledge, have courageously taken on. As early as October 30th, 2017, a mere 11 days after the initial discovery of Oumuamua, a testament to the urgency and excitement it generated, researchers from the Initiative for Interstellar Studies, or I4IS, announced the ambitious launch of Project Lyra. This groundbreaking project was specifically aimed at assessing the fundamental feasibility of designing a mission that would send a dedicated spacecraft after the interstellar object, to pursue it across the vast gulfs of space, with the ultimate goal of studying it up close, to finally put to rest the lingering questions about its true nature. This is not just a mission of discovery, but a monumental scientific and engineering challenge, a testament to human ingenuity and cosmic curiosity, pushing the boundaries of what is conceivable. But is such an incredibly ambitious mission even remotely feasible with our current or near-future technology? The distances are astronomical, the speeds immense, the target tiny. Engineer and scientist Adam Hibbard, a key participant in Project Lyra and the brilliant mind behind the Optimum Interplanetary Trajectory Software, OITS, a sophisticated program used for calculating optimal trajectories for complex interplanetary missions, an essential tool for navigating the solar system, is utterly convinced. He believes the mission is not merely about finding out what Oumuamua truly is, satisfying a specific scientific curiosity. It represents an unprecedented chance, a monumental opportunity, to make a profound breakthrough in our fundamental understanding of the entire interstellar realm, to push the boundaries of what humanity can achieve in space exploration, to literally reach out and touch another star system. According to him, the critical first step in such a monumental undertaking is the creation of a truly unique and extraordinarily resilient probe, one capable of not only reaching Oumuamua, but also of withstanding the unimaginably harsh and unforgiving conditions of deep interstellar space for decades, if not longer. This probe must be robustly and reliably protected from the relentless onslaught of cosmic radiation, for it will need to traverse billions of miles where such radiation is ceaseless, intense, and potent enough to easily disable or irrevocably damage its delicate scientific instruments and electronics, turning it into a silent, useless hulk. It will require a new generation of hardened components and autonomous systems. Of course, the task of physically catching up with ʻOumuamua, which is already hurtling away at tremendous speeds, is not an easy one. It is a monumental challenge demanding ingenuity, advanced physics, and technological advancement. However, in the realm of space mission practice, we have already accumulated considerable knowledge and developed sophisticated techniques to achieve extreme speeds without resorting to massive, impractical rocket engines or carrying colossal reserves of fuel, which would be prohibitively heavy, expensive, and logistically complex. The key lies in leveraging the natural forces of the cosmos. As a core part of Project Lyra's detailed engineering proposals, engineers plan to launch a probe on what would truly be a dizzying, multi-stage journey, strategically utilizing a series of gravitational assists, essentially employing massive cosmic bodies as powerful slingshots to impart immense speed. One of the proposed trajectories for this interstellar chase is a true, intricate planetary dance, a carefully choreographed ballet of physics. The probe would initially launch from Earth, embarking on a carefully timed trajectory that would bring it towards Venus, where it would receive its crucial first gravitational boost, accelerating it significantly. It would then loop back towards Earth, precisely timed to use our own planet's immense gravity for a second, even more powerful acceleration. The next, and arguably most critical step would be to fly toward Jupiter, the gas giant, where its immense gravitational field, the most powerful in our solar system, would impart the final colossal push, sending the spacecraft hurtling on its way toward the elusive interstellar traveler, Oumuamua, with unprecedented speed on its final trajectory out of the solar system. Additionally, the probe itself would be meticulously equipped with advanced chemical propulsion systems. These onboard engines would not be for the primary acceleration, which comes from gravity assists, but would serve a crucial role in fine-tuning its trajectory with exquisite precision and providing additional, smaller bursts of thrust at precisely the right moments, should course corrections be necessary to hit a tiny target billions of miles away. This is because, in an interstellar chase where distances are astronomical and time scales are vast, every single mile per second of velocity counts, making the difference between success and failure. A slight error early on accumulating into a monumental miss. This ingenious trick of using gravitational assists has already stood the test of time and proven its immense value in human space exploration. In 1979, the legendary Voyager 1 and Voyager 2 spacecraft famously used Jupiter's gravity to accelerate dramatically, redirecting their paths and sending them hurtling towards Saturn and beyond, eventually out of our solar system entirely. Today's visionary engineers, drawing inspiration from these historic achievements, aim to replicate and even surpass this maneuver. But this time, with the explicit and monumental goal of catching up with Oumuamua, a ghost of another star, a cosmic first. There's also another far more daring and technically challenging plan being considered, one that pushes the very limits of our engineering and material science, known as the solar O-berth maneuver. In this audacious scenario, the probe would first embark on a journey to Jupiter, where, instead of merely accelerating, it would execute a complex maneuver to reduce its speed relative to the solar system, using the giant planet's gravity to precisely change course and direct itself towards the Sun. The goal would be to approach our star as closely as physically possible, daringly skimming its superheated corona, without, of course, catastrophic consequences for the spacecraft itself. There, at the very edge of hell, subjected to unimaginable temperatures and radiation, it would receive a truly massive gravitational boost from the Sun's immense pull, a cosmic slingshot of unparalleled power. Crucially, at the moment of its closest solar approach, it would additionally ignite its chemical engines, utilizing the Oberth effect to its absolute maximum potential to escape the Sun's powerful gravitational embrace with unprecedented, almost unbelievable velocity. Then, at truly incredible, almost unfathomable speeds, it would perform a return slingshot past Jupiter, using its gravity once again for further acceleration, finally entering a trajectory specifically designed to pursue Oumuamua across the vast interstellar distances, accelerating to a speed that would minimize the travel time. If everything works out perfectly, if every complex maneuver is executed with flawless precision, if the heat shield holds and the engines fire on cue, the spacecraft could potentially accelerate to speeds ranging from an astonishing 74,000 miles per hour, or even up to an incredible 163,000 miles per hour. That translates to approximately 20 to 45 miles per second. This is precisely the speed range needed to catch up with the fast-fleeing mystery object, and to do so within a reasonable time frame for scientific study, perhaps bringing the journey down to a few decades instead of centuries. However, there's a serious and formidable obstacle inherent in the solar Oberth maneuver: the colossal temperatures. Approaching the Sun so incredibly closely, daringly skirting its fiery outer layers, could heat the probe to an astounding 400 degrees Celsius, 550 degrees Fahrenheit. This is a temperature hot enough to instantly melt most metals, turning them into molten liquid. The probe would essentially be flying into a furnace. However, humanity has already developed and proven a solution to this infernal challenge, a testament to our engineering prowess and innovative spirit. The groundbreaking Parker Solar Probe, a marvel of modern engineering, in 2024 set an astonishing new record by approaching the Sun at just 3.7 million miles from its surface, well within the Sun's corona. It achieved this unprecedented feat thanks to its unique, cutting-edge heat shield, known as the Thermal Protection System, TPS. This shield is primarily made of two panels of superheated carbon-carbon composite, sandwiching a lightweight 4.5-inch thick carbon foam core. This ingenious design, often coated with a special white ceramic to reflect sunlight, allowed the probe to withstand the infernal heat, keeping the sensitive instruments behind it at a relatively comfortable 85 degrees Fahrenheit. A similar, equally robust shield, adapted for even higher speeds and longer exposure, is meticulously planned for the probe destined to chase Oumuamua. In fact, engineers have already created detailed 3D models of this hypothetical spacecraft, visualizing its journey and its protective skin, bringing it closer to reality. Scientists have not yet made a final, definitive decision on which daring route to choose for the probe: the intricate gravitational assist dance involving Earth, Venus, and Jupiter, which is safer but slower, or the perilous, yet potentially much faster, solar flyby. Each option presents its own unique set of advantages, challenges, and risks. Other, even more exotic and futuristic propulsion methods are also being actively considered, pushing the very boundaries of our technological imagination and theoretical physics. For instance, there is the concept of laser propulsion, a visionary technology in which a powerful, ground-based laser system would project a focused beam of energy onto a lightweight sail attached to the probe, literally pushing it through space, giving it immense acceleration without requiring a single drop of onboard fuel. Or the previously mentioned solar sails, those elegant, lightweight, expansive structures designed to capture the subtle pressure of sunlight, gradually but surely accelerating the spacecraft across the immense, silent cosmos, like a ship riding the stellar winds. While powerful ground-based lasers for interstellar travel are still in their infancy, the principles are sound, and small-scale experiments are ongoing. For now, these advanced, more exotic technologies remain more experimental, more theoretical, than immediately practical for a mission of such complexity and scale, particularly one with a tight launch window. However, they undoubtedly open the door for a new, revolutionary era of fast, efficient, and potentially interstellar travel, allowing us to venture further and faster than ever before, transforming science fiction into scientific reality. As for the specific mission to reach Oumuamua, its launch is tentatively scheduled for sometime between the years 2030 and 2033, a testament to the long-term vision and commitment required for such deep space endeavors. The most realistic and technologically achievable scenario at this point in time involves the intricate gravitational dance using Venus, Earth, and Jupiter. In this carefully planned event, the probe will be able to catch up with the fast-receding Oumuamua in the early 2050s, perhaps somewhere around 2052. If successful, this would represent a truly monumental achievement. For the first time in human history, we would come face to face, up close and personal, with a physical messenger from another star system, holding the potential to unlock secrets unimaginable, to redefine our understanding of cosmic life and technology. But what if the mission, despite all the ingenious planning, the cutting-edge technology, the unwavering dedication, and the decades of effort, ultimately fails? What if the probe, after its decades-long journey spanning billions of miles, is simply unable to catch up with the elusive Oumuamua, which is now accelerating rapidly away from our solar system, deeper and deeper into the void, a ghost forever out of reach? What if, even if it does manage to approach the object, it does so from a distance too far away, too remote, to study it properly, to gather the crucial, definitive data needed to understand its nature? We must not forget that this object is, by cosmic standards, extremely small, emits no light of its own, and, critically, sends no detectable signals. Spotting such a tiny, silent, dark object in the vast, featureless expanse of deep space is an almost impossible task, akin to finding a single, unlit matchstick in an infinite, darkened warehouse, a search demanding incredible precision and luck. There's another significant risk, a daunting technical challenge inherent in such high-speed intercepts. The probe could potentially reach its target, but then fail to slow down sufficiently in time to conduct its observations. In that harrowing scenario, it would simply speed past Oumuamua, a fleeting blur in the cosmic distance, tragically missing what might be our only, solitary chance to get close to our elusive, enigmatic target. Such a high-speed flyby would only allow for a few seconds or minutes of data collection, a tantalizing but insufficient glimpse. The precision required for a successful rendezvous and sustained observation is immense, demanding flawless execution. Despite these formidable obstacles and potential pitfalls, scientist Adam Hibbard, with a characteristic blend of pragmatism and profound vision, believes that even in the unlikely event of such a failure to fully rendezvous with Oumuamua, the mission would by no means be considered a true failure. Its value would extend far beyond its primary objective, even if Oumuamua itself proves uncatchable, forever receding beyond our reach. The probe would nonetheless achieve a monumental feat. It would become the very first spacecraft in human history to be purposefully and intentionally sent beyond the traditional boundaries of our solar system, specifically designed from its inception to venture into the true interstellar medium. This alone would be a paradigm-shifting accomplishment, a leap for humanity into the galactic ocean. The audacious attempt to chase Oumuamua is, therefore, also a profound chance to study and explore the vast, unknown space beyond our solar system, to gain an understanding of the universe from an entirely extrasolar perspective. This unprecedented journey, the scientist asserts, could bring humanity countless, invaluable benefits, expanding our knowledge in ways we can only begin to imagine, opening new fields of scientific inquiry. To date, only 2 man-made objects have ever successfully crossed the heliopause, the theoretical boundary where the sun's influence, particularly the solar wind, dramatically weakens and interstellar space truly begins. These are, of course, our venerable pioneers, Voyager 1 and Voyager 2, launched in the 1970s. But their incredible journey beyond the solar system was, in many ways, more a matter of fortuitous luck and astonishing longevity than deliberate, pre-planned design. No one, when these probes were initially conceived and launched decades ago, ever truly expected them, designed primarily to study the outer planets, to travel so incredibly far, or to function for so astonishingly long, continuing to send back faint signals from the edge of the unknown. Unlike the Voyagers, however, the new Project Lyra probe is being meticulously designed from its very inception with the explicit purpose of venturing deep into interstellar space. It will be custom-equipped with state-of-the-art instruments, cutting-edge sensors, and advanced communication systems, all specifically engineered to withstand the extreme conditions of the interstellar medium and capable of gathering invaluable data about that hitherto unexplored environment beyond the solar system. This is data that we simply do not possess, a fundamental void in our cosmic understanding, waiting to be filled. In that transformative scenario, the probe would not only retain a chance, however slim, to catch up with Oumuamua and definitively answer the profound question of what this object truly is, but it would also, regardless of its ultimate rendezvous, transmit invaluable data about the myriad mysteries of interstellar space back to us, enriching our understanding of the galaxy we inhabit, becoming our first true interstellar scout. But what exactly do scientists, with all their meticulous planning and fervent hopes, truly hope to see if the Project Lyra probe does manage to reach Oumuamua and successfully study it up close? The possibilities are as vast as the universe itself. As already mentioned, most researchers, leaning towards the naturalistic explanations due to scientific conservatism, believe this mysterious visitor is nothing more than an unusual comet or an asteroid, a fragment of another stellar system, albeit one with some highly anomalous characteristics. It's assumed to be a dense object, primarily composed of rock and possibly various metals, hardened by its long interstellar journey, its surface sculpted by eons of cosmic radiation. Crucially, in this naturalistic view, it contains little to no water or ice, a key factor in its lack of a visible cometary tail. Its reddish surface, a subtle hue observed by distant telescopes, is likely the result of eons of relentless exposure to cosmic rays and energetic particles, which have chemically altered its outer layers over millions upon millions of years, slowly baking and darkening its surface. If the probe were to confirm this, providing high-resolution images and spectroscopic data, it would confirm a new class of interstellar object. If it proves to be a natural object, the probe would seek to precisely determine its composition. Is it nitrogen ice, as suggested by Jackson and Desch, confirming a piece of a Pluto-like exoplanet? Or is it a hydrogen-rich comet, as theorized by Seligman and Bergner, demonstrating a new mechanism for cometary outgassing? Or is it simply a peculiar dust-poor rocky asteroid, as Karen Meach suggested, perhaps from a system that formed differently than ours. Direct measurements of its density, its surface features, its internal structure, perhaps with radar, and its exact spectral signature would resolve these debates. High-resolution imaging would also definitively settle its shape, whether cigar-like, pancake-like, or something entirely unexpected, revealing its formation history. Understanding its precise chemical and isotopic composition could even tell us about the conditions of the star system from which it was ejected, providing a direct sample of exoplanetary material without having to send a probe there directly. This would be a treasure trove of information about planet formation in other star systems. Once scientists formed a general idea, or at least several competing hypotheses, about the composition of Oumuamua, it begged the next question, one just as important and deeply intriguing. What kind of incredible journey brought this object to our particular solar system? The answer to its true nature, the ultimate key to understanding its identity, might lie not only in what it's made of, but just as profoundly in where it came from, the distant stellar nursery that gave it birth, the cosmic forces that propelled it on its epic voyage. Tracing its origin could reveal the galactic highways that lead to and from other stars. In 2018, astronomers, pooling their collective knowledge and computational power, attempted the formidable task of retrospectively reconstructing Oumuamua's trajectory, tracing its path backward through the labyrinthine cosmic currents of our galaxy, accounting for the gravitational pulls of countless stars. Their meticulous calculations, performed with highly precise astrometric data, revealed that approximately 1 million years ago, a mere blink in cosmic time, but an immense span in human history, it flew past several stars, coming closest to a faint red dwarf star designated Hepi 3757. Red dwarfs are the most common type of star in the galaxy, long-lived but often dim. It is entirely possible, therefore, that its long, silent, interstellar journey, its epic voyage across the galaxy, might have begun there, originating from that distant stellar system and heading directly, inexorably, towards us, perhaps a fragment from a planetary system around HIPP 3757. Another compelling version of its origin story, equally intriguing, suggests that Oumuamua might have come from the Vega star system, a bright and prominent star in the Lyra constellation, located approximately 25 light-years away from us. Vega is a much younger, hotter, and more massive star than our Sun, known for its rapid rotation and a prominent dust disk that might host planets. So far, astronomers, even with their most powerful instruments, have not yet found any definitive, potentially habitable planets in that immediate region of space around Vega. But that absence of evidence, it is crucial to remember, is not evidence of absence. Our detection capabilities are still limited. It is quite possible, indeed tantalizingly probable, that somewhere near Vega, or a star similar to it, perhaps a planet or a hidden moon, a civilization exists, a silent, unseen intelligence that might, just might, be responsible for the appearance of this mysterious object in our solar system, stirring all this excitement and intellectual fervor in the scientific community. Finding a techno-signature would be the ultimate prize, and if Oumuamua were to be confirmed as an artificial object, the implications would be staggering. The probe could search for any active systems, power sources, communication antennae, data storage devices. Even if inert, its construction materials, alloys, or advanced composites would speak volumes about the technology that created it. The engineering principles of an alien civilization would be laid bare. Imagine detecting traces of a miniature nuclear power source, or incredibly resilient nanocomposites that make our best materials look primitive. Such a discovery would not just be scientific. It would be philosophical, sociological, and perhaps even spiritual, shattering our cosmic isolation and forever changing humanity's place in the universe. It would force us to confront our assumptions about life, intelligence, and destiny. Now, in the present moment, as these vast, cosmic narratives unfold, Oumuamua continues its silent, relentless journey, speeding toward the constellation Pegasus, an almost poetic continuation of its strange voyage through the fathomless depths of space. By the end of 2025, this interstellar visitor will reach the outer edge of the Kuiper Belt, that vast, icy disk of comets and dwarf planets beyond Neptune, marking another milestone in its departure. And by November 2038, just 13 short years later, it will cross the heliopause, the very boundary we discussed, where the sun's influence ends, thus formally exiting the region dominated by the solar wind and truly entering the unadulterated, cold vacuum of true interstellar space, lost to our direct observation forever, becoming a true galactic wanderer. Its journey from obscurity to mystery and then back into the deep dark will be complete. Oumuamua appeared very suddenly, a fleeting ghost in the cosmic night, a brief, stunning apparition that defied explanation. And then it disappeared just as quickly, receding with the same silent, inexplicable grace, leaving behind far more profound questions than definitive answers. Its brief, enigmatic presence stirred the scientific community to its very core, igniting a fervent desire for deeper understanding, a commitment never to be caught so unprepared again by such an interstellar visitor. And now researchers across the globe are fiercely determined not to miss the next such visitor from the unimaginable depths of space, to be ready, poised, and equipped, to welcome the unknown with open instruments. In response to this new era of interstellar visitors, the European Space Agency, ESA, is meticulously preparing a unique and visionary mission, aptly named Comet Interceptor. Its groundbreaking goal is not to chase a known object, which is often too late, but to be ready to intercept future objects arriving unexpectedly from interstellar space, or even long-period comets from the Oort cloud. But here lies the main challenge, a profound logistical hurdle. These kinds of guests, particularly interstellar ones, arrive at truly incredible, often unexpected speeds, and their trajectories are only confirmed once they are relatively close to our sun. There is simply not enough time, not enough lead time, to prepare, design, build, and launch a dedicated spacecraft from Earth once such an object is spotted and its trajectory confirmed. The window of opportunity closes too quickly. Therefore, ESA, with a forward-thinking and bold strategic decision, has devised an ingenious solution. In 2029, they plan to launch a stakeout probe into space, a patient, autonomous sentinel that will be stationed at the Sun-Earth Lagrange point L2. This is a gravitationally stable location, approximately 930,000 miles from Earth, well beyond the Moon, where the gravitational forces of Earth, the Moon, and the Sun balance out, creating an ideal, stable observational outpost. It is a perfect parking spot, requiring minimal fuel to maintain its position relative to Earth and the Sun. There, at this celestial crossroads, the probe will wait patiently, almost silently, like a hunter in the dark forest of space, for up to 3 years, or even longer, depending on its operational lifetime. As soon as an interstellar comet or another exotic visitor appears on the horizon, identified by our ground-based telescopes and quickly analyzed, the Comet Interceptor will activate. The main probe, acting as a command center and communications hub, will then swiftly release 2 smaller, highly maneuverable satellites. These daughter probes, lightweight and agile, will then converge on the target, pinching it, and beginning simultaneous observations from multiple angles, creating an unprecedented 3D profile of the object, revealing its secrets in a way a single probe never could. This proactive, ready and waiting approach represents a monumental shift in our strategy for engaging with the mysteries of interstellar space, moving from reactive observation to proactive interception. The Comet Interceptor mission, if successful, promises to answer many questions that Oumuamua left behind. If it encounters another dust-poor comet, it could confirm the theories about hydrogen outgassing or nitrogen ice. If it finds an object with a truly anomalous shape or composition, it would provide direct, unambiguous data for further scientific inquiry, potentially rekindling the artificial origin debate with new vigor. The multi-angle observation will be crucial for understanding complex cometary activity, or for detecting subtle features that might be missed by a single flyby. This mission isn't just about comets. It's about being prepared for the truly unexpected, for the next messenger from afar, whatever its nature may be. Most scientists today, after weighing all the accumulated evidence and considering the naturalistic explanations with rigorous scientific methodology, believe that Oumuamua is, despite its perplexing anomalies, an ordinary cosmic body, most likely a comet or an asteroid, a fragment of another stellar system. They base this on the statistical likelihood of natural processes over artificial ones, especially without any direct, unambiguous technosignatures. Others, however, guided by the persistence of its unexplained characteristics, its unusual trajectory, and the profound implications of its precision, continue to suggest that we might be dealing with technology, with an artifact from another civilization, a silent, inscrutable visitor, engineered by an unseen intelligence. But, crucially, as of this moment, we cannot definitively confirm either hypothesis with absolute certainty. The object is already too far away, receding beyond our reach, and its true nature remains cloaked in mystery, a cosmic secret held tightly in its silence, a question mark floating in the dark. The chase for the truth, this grand, scientific pursuit, seems almost impossible, fraught with immense engineering and financial challenges, inherently risky and absurdly ambitious. But it is precisely these kinds of profound, overarching mysteries, these seemingly insurmountable scientific challenges, that ignite the human imagination, that fuel our deepest curiosity, and that ultimately drive us, as a species, to push the boundaries of what is possible, to build the next generation of telescopes and spacecraft, to look further, to listen more intently, to explore more bravely. The burning desire to truly know, to understand our place in the vast, silent cosmos, far outweighs all the obstacles, all the risks, and all the expenses, for the answers could redefine our very existence. So as these thoughts drift through your mind, as the quiet of the night deepens around you, as your consciousness gently expands into the cosmic realm, what do you think truly flew past us in 2017, stirring such profound questions and setting in motion such ambitious future plans? Was it an ancient, silent comet, a natural wonder from another star, a piece of cosmic flotsam, or something more, something deliberately crafted, something that embodies the intelligence of another species? And should humanity, with its finite resources and pressing terrestrial concerns, truly dedicate itself, its ingenuity, and its treasury to such audacious missions, chasing ghosts across the interstellar sea, or preparing to intercept the next one? Share your thoughts, your quiet speculations, your deepest ponderings in the comments below as we continue to grapple with the greatest mysteries of the universe and allow the gentle hum of cosmic wonder to lull you into a state of deep, reflective rest, where dreams of distant stars and silent messengers can unfold. The universe whispers, and we, quietly, listen.